watch me grow and start participating in this incredibly dynamic community. So thank you so much for giving me the honor to speak in front of you today. So today I'm going to be talking to you about Sail and kind of developing a strategy for navigating the DOM APIs and eventually coming to write your own framework. So first, a little bit about me. My name is Kitt, as Troy has already told you, and I'm a front-end engineer at Voxer. There are two unique things about Voxer that have directly contributed to me formulating this talk. The first is that we have a very fledgling web presence. Our core product is actually a smartphone app for Android and iOS devices. And until about 4 months ago, we've never really had the incentive or impetus to look at the web as a platform for accomplishing any particular objectives. But a while ago, we released a business product that allows administrators to actually manage users and teams for their own businesses, and then take a version of our app and use it for cross-collaboration within those particular teams. So having a particular admin portal that's dedicated to that task is fundamental. And the way we did that was by writing a single-page dynamic web application for that portal. The second part about Voxer is our use of Node. Our backend is actually written entirely in Node.js, all of it. And so we've embraced the Node.js philosophy of having a few low-level core methods that allows us to actually build what we need on top of that. So we're very big about using special modules that are particularly suited to the tasks at hand without having to necessarily settle for general-purpose solutions. And on that note, we've tried to take that and apply it to our experiences in front-end development. So sometimes it makes sense to use an existing third-party solution. Whether you're a seasoned dev or you're just getting started, the amount of logistics that are involved in building any kind of complex app is staggering. Which resources do you use? How do you best maximize them? Which framework do you go with? Do you go with the most popular one? Do you choose a more esoteric approach? How likely is it that you'll be able to find resources to help you in your quest to do that? And do you even need a framework? Do you feel comfortable enough with your skills that you could approach writing a single-page app without using any third-party framework at all? So the point of this talk is to empower you to hopefully make a decision based on that. Some of you may elect to continue using existing third-party solutions, or sometimes you might elect to chart your own course. So this talk will outline some of the lessons that I personally learned at Voxer going with the latter option, and that is charting your own course for trying to build your own framework. So regardless of which framework you choose, pardon me, there are a lot of third-party frameworks that are available out there. So jQuery, MooTools, YUI. And regardless of whichever one you choose, it'll undoubtedly incorporate some of the features that are listed here. So the attraction of one of these frameworks is that you don't need to fully understand the underlying abstractions to build an app. For instance, you can have access to a CSS selector engine, methods for manipulating styles, attributes, properties, positioning, and some sort of plugin architecture so they can build your own code on top of the framework. And the attraction is that you don't need to fully understand how the DOM works in order to get started with one of these frameworks. You just drop it in and go ahead and begin hacking. Unfortunately, that library also has a trade-off, and that is introduces an additional degree of separation, or a layer of abstraction, between the DOM and your application logic. So it takes a lot of cognitive overhead to understand how precisely all the ins and outs of your app work, not to mention the overhead involved in debugging the application when it comes to it. So some of the lessons that we learned at Voxer while trying to build our own framework is to first of all simplify. Find problems in disguise and reduce them to an absolute bare problem. Sometimes when you approach a particular problem in front-end scripting, chances are there's a low-level method or a low-level approach that you can follow that will allow you to then build your solution on top of that. Let me give you an example in the form of element storage. As soon as... There we go. Perfect. So element storage was a feature that was initially popularized by MooTools, then implemented by Prototype, and currently implemented in all major frameworks. The premise of that is simple: to allow devs to arbitrarily associate metadata with any particular element. So a naive solution would be to attach properties directly to that element. Unfortunately, this has two side effects. The first is that it'll leak memory in older versions of IE, specifically IE 8 and older, and it also violates the principle of modifying objects you don't own. Also, keep in mind that the DOM is a staggering collection of different APIs. They implement a lot of magic getter and setter properties, and so the chances for naming collisions are extremely high. So for that reason, you want to avoid adding your own methods and properties to individual DOM nodes or elements as if they were any other property on top of that. So let's go ahead and take a deeper look at this problem. The solution that most frameworks have adopted is to maintain our own data store with data indexed for each element by some sort of unique element identifier. So unfortunately, browsers don't provide unique identifiers for most elements, but if you look in the specs, IE actually implements a unique number property on element, comment, and document nodes. So this is quite elegant because it allows us to work around two other particular bugs present in these older versions of IE. The first is that IE7 and older will conflate attributes and properties. So if you attempt to set a custom expando identifier on every element and then access the element's outer HTML or the inner HTML of its parent, you will actually see that custom property appear serialized as an attribute. That's not good because it creates a leaky abstraction. Secondly, the clone node implementation of these browsers will actually clone expando properties as well. So your unique identifier is effectively no longer unique. But unique number allows us to neatly sidestep this. So we can go ahead and write a feature test for that. Now notice that we've already gone ahead and reduced the problem of element storage to an identify elements uniquely solution. We can go ahead and write a simple function and then use standard JavaScript semantics, an object literal with keys being the unique elements identifier, in order to actually store metadata. So how would you learn about extensions like this? Let's say that you're interested more in the process. Well, this particular extension, unique number, is a non-standard Microsoft one, so it's not in the DOM spec. However, Microsoft has actually published a spec on MSDN called HTML 4.01e, which details all of these extensions. So it's just a Google search away if you're interested in finding these kinds of interesting goodies. So we can go ahead and then write our identify function that looks like this. So it's a reference implementation. You don't need to so much worry about the code, but you can see that we're testing for the unique number property, falling back to our own custom expando. Because other browsers don't have the attributes versus properties conflation, we don't need to worry about that. But even so, you'll notice that this function is relatively simplistic. I did this primarily so that it could fit on the slide, but you'll notice, for example, that we don't account for cross-frame compatibility. That's something that leads nicely into my next point, and that is the perils of generality. So frameworks like jQuery, MooTools, and YUI need to offer general solutions because they can't possibly anticipate how devs are going to be using them. Now this is again good for the developer because they don't have to worry about the underlying bugs or abstractions. The framework handles it all for you. But unfortunately, this means that these frameworks have to always assume the worst and account for as many edge cases as possible, because there is going to be at least one developer who wants to use a particular method that may be buggy cross-browser. So the framework has to incur the additional overhead of specifically normalizing for that particular one. Let me give you a few examples. For instance, handling attributes and properties. So before doing so, it helps to provide you with some context. Attribute handling has traditionally been a very weak area in most client-side frameworks. For instance, from about 2006, when jQuery was created, until 2010, when version 1.6 was released, jQuery's pivotal ATTR method conflated attributes and properties. And thanks to the efforts of amazing devs like Timmy Willison of the jQuery core, devs have become more aware of the issues. However, this does raise another interesting point, and that is framework-specific abstractions can sometimes lure developers into a false sense of security about how a particular API works. For instance, many devs, when they use jQuery's ATTR, assume that it transparently handled both attributes and properties. So when version 1.6 was released, many devs' code broke because when they thought they were manipulating attributes, they were actually manipulating the reflected properties and not accounting for the various bugs. So when frameworks fix these bugs, it allows devs to correct that understanding. But still, without having that low-level knowledge of the underlying abstractions, it's always up to the framework to try to push you forward, not necessarily the developer themselves. But first, a brief recap about attributes and properties. Some of you may not necessarily be familiar for the distinction between them. What's also intriguing is that the specs are incredibly ambiguous on this point as well. They define attributes as content attributes, ones that appear in the source, and they define properties, or what we think of as properties in JavaScript, as IDL attributes. IDL stands for Interface Definition Language. It's the language that the W3C uses to specify the various DOM interfaces. So because of this ambiguity, it's incredibly difficult to even begin to comprehend how attributes and properties work. So let me go ahead and try to clarify that bit for you. Attributes are set directly in the HTML source. They have semantic meaning, and they provide additional information about the element, be it its behavior, contents, or presentation, just some additional tidbit about the element. And this is a known list of buggy attributes across browsers. Every single one of these has a bug. Most of these transgressors are Internet Explorer 8 and older, and Opera 9.5 and older. So the Opera version is not much of a concern, but Internet Explorer 8 is certainly still in use, especially given that it's the maximum browser that Windows XP, it's the maximum version of IE that Windows XP users can run. And even though Microsoft is scheduled to sunset support for Windows XP in 2014, their IE8 still enjoys a large market share. So devs still need to continue to support these older versions of IE if they're really interested in supporting those XP users and cannot, for whatever reason, encourage them to upgrade to another browser. So let's go ahead and look at properties now. Properties are set directly in the DOM, and they usually reflect attribute values. So for the most part, modifying a particular property within the DOM will affect the reflected attribute and vice versa. The reflections aren't always clear-cut. There are a few intriguing distinctions for form controls, for example, but it is something that it's a behavior that's widely specified. They're a better alternative to manipulating attributes directly, especially given the bugs in IE, but they're not without their flaws. And as with attributes, the primary transgressors are IE8 and Opera 9.5. But nonetheless, if you are writing a general solution, you have to assume that at least that one developer will end up using or trying to access one of these properties. jQuery 1.6, in their divergence between attributes and properties, actually introduced a prop method, which you can use to access or set properties on an element. And unfortunately, it's not as clear-cut as simply using square bracket notation to access a property by a string. There are certain property values that will throw exceptions if they're set. And also, keep in mind that HTML5 defined an entirely new set of attributes to put onto elements, which invariably means that there is an increase in the set of reflected property names. But older browsers don't support those reflected properties because to them, the new HTML5 attributes are meaningless. They have no intrinsic value. But nonetheless, if you're writing a general solution, you have to be able to account for them because you cannot anticipate how developers will be using them. To add insult to injury, many of these attributes and properties are actually deprecated. In fact, browsers like Firefox have gone to efforts to remove some of them, like the profile attribute of head elements, for instance, and then their corresponding property reflections. But the majority of browsers still have to support them because a significant overhaul in attribute and property handling will break the web. But if you're writing a general solution, you've actually committed yourself to supporting them as well. Whereas if you're creating a more tailored solution for a highly specific set of cases, then you can avoid the burdensome task of having to solve every single problem that comes your way. So what are some considerations that you should keep in mind? One of the most important takeaways is opportunity cost. It's a concept from economics, and it refers to the sacrifice related to choosing the next best alternative. Compounding that, it basically means that there is no free lunch. Every decision involves a trade-off of some kind. And I'd like to go ahead and go over some of those trade-offs with you now. The very first one is file size. One of the hallmarks of the node philosophy that we heavily embrace at Voxer is for us to create modules, not monoliths. We write small, focused bits of code that do one thing well for our particular use cases. And in the front-end world, we've taken to calling these certain modules micro-libraries. The problem with micro-libraries is that most of them overwhelmingly emphasize size above all else, which is good. You want to avoid having to download a bunch of cross-compatibility code if you're working on a mobile browser, because chances are your mobile browser is modern enough that it supports most of the standard methods, and you don't have to implement all these crazy hacks that you would for older desktop browsers. But nonetheless, what a lot of devs have started doing is taking micro-libraries and using them as general solutions. In fact, you will find micro-libs that claim to offer jQuery-compatible or MooTools-compatible APIs that say that you can have all of jQuery's API in about half or a fourth of the size. The problem is most of those APIs don't support any kind of normalization or perform feature tests. In fact, there are some APIs that are just thin facades over individual native DOM methods, which is okay, except you have to remember that native doesn't really mean much. Let me give you an example. According to caniuse.com, query selector all is implemented in over 90% of browsers now. So it should be safe to query the DOM using arbitrary CSS selectors, right, without needing to implement a third-party solution like Sizzle or NW Matcher. Well, not really. You see, one of those browsers that supports native query selector all is IE8. And even though IE8's implementation is mostly compliant, there are a lot of bugs in its handling of attributes and form controls that make query selector all unsuitable for those cases. So you still have to feature test for those additional bugs and then come up with your own creative solution for working around them. And the problem with using microlibraries in general is that they lull devs into a false sense of security. You think that you can have all the benefits of a larger framework in about a fourth or a third of the size. But with that comes costs for compatibility and additional overhead. And now, because you're treating that microlib as a general solution, you're effectively insulated from any bugs that you might experience. So you might be able to test that in a modern browser like in Chrome, or even a mobile one like mobile Safari or Chrome for Android. But then you go back and test it in some older desktop browsers, or test it in an older mobile browser where the standards aren't quite as fully baked. And suddenly, you're starting to encounter a lot of bugs in your code that you are then going to have to work around manually. There is a reason that general-purpose solutions like jQuery and MooTools are so complex, and that is because they have to account for every single possible use case. So don't be fooled into thinking that you can use a microlibrary in order to work around every single property bug, because it's not. A particular solution is, the more intricate it has to be, and the more different layers of abstraction it involves. And finally, all these different workarounds have a negative impact on performance. Because again, your framework needs to be able to account for every possible edge case and try to work around it as needed. So even if you're passing, let's use the example of attributes. Even if you're passing in an attribute that is known to work consistently across every browser, there is still an overhead that the framework has to incur because it needs to check to make sure that the attribute you're passing in isn't buggy. So even though the engine might not end up having to take that path at all, the fact that you have to include in your code increases the file size and increases the performance overhead as well. So what I'm trying to get at here is that there is no particular panacea for any solution. If you start out rolling your own, you do have to be aware that you cannot begin by implementing a general solution. If you want to use a microlibrary, you have to be aware of the general limitations of it and accept that you cannot rely on it to provide a general solution. And you also have to realize that every time you insert an additional layer of abstraction into your app, you have to think about the performance cost. So what are some of the lessons that we learned at Voxer while trying to roll our own utility methods? The first one is to write low-level targeted utility libraries, ones that work particularly well for our use case. Going back to the attributes and properties example that I mentioned, the content editable property and its corresponding attribute are buggy in older versions of IE, which only accept one of 3 values. If you set any other value attempted, it'll throw a type error. So frameworks like jQuery have to normalize it to make sure that you're giving it the correct value. But at Voxer, for instance, and I'd imagine for many apps, you will never want to manipulate this attribute directly. So in that case, you don't have to incur the overhead of attempting to create a general solution that handles every single one of these edge cases for you. The second one is to stop writing library plugins. Chris Heilman of Mozilla gave an excellent talk at HTML5 DevConf that outlined the limitations of general purpose abstractions. And the problem is that they are entire abstraction layers with a completely different syntax, sometimes removing developers from the inner workings of the DOM. So Chris suggested learning and targeting raw DOM APIs instead, because it puts you much closer to how the browser actually parses and renders your page, and also allows you to gain a lower level understanding of how those different bugs can be targeted. The last two relate to cross-browser consistency. The first is not to aim for identical experiences in every browser. A lot of devs, when they look at the term cross-browser consistency, interpret that as meaning that your method should behave identically in every single implementation, and that you should attempt to normalize it as much as possible. This is true for lower-level methods, on which you're attempting to build other layers of your app. But for other apps, it doesn't matter so much if you have a particular method that, or if you're using a particular feature that works in one environment but not the other. Let me give an example. CSS3 animations and transitions. You can use CSS3 to provide effects that previously you could only do with a third-party framework like Scriptaculous or jQuery's UI. The problem, though, is that CSS3 animations are actually hardware accelerated. They take advantage of the GPU so that as the CPU can continue processing your code and executing other instructions. And this is particularly important on a mobile device where resources are always limited. So you can go ahead and try to use a library that provides a simulated fallback for these transitions in older environments and uses the CSS3 hardware accelerated transforms in the newer ones. But again, chances are those older environments are not optimized to execute that code. What you're basically doing is saddling those older users with an inferior experience. You're slowing down their browser in order to, all in the name of providing an identical experience. And plus, there are the inevitable differences in rendering engines across browsers. As Chris said, if you truly want to provide an identical experience for every single browser under every possible configuration, your only solution is to serve JPEGs. That's it. But cross-browser consistency still matters for lower-level methods. I'd like to go ahead and point you to this quote. It's one that Garrett Smith wrote in 2010 in a comprehensive evaluation of CSS selector engines in various libraries. Now, to their credit, many of these libraries have improved their engines to the point of where many of those criticisms no longer apply. However, the advice that Garrett gave still remains sound. Before attempting to fix any bug or introduce a new feature, developers first have to understand the problems and the underlying abstractions that their code uses. And likewise, keeping in mind that any change to a lower level abstraction will automatically propagate to all of its dependencies. Coming back to the earlier example, it doesn't so much matter if you have an animation that works in the latest version of Chrome but doesn't work in IE8 or IE7. That's not a problem. It doesn't really hinder the user experience that much, and the user still has a baseline experience that they can access. However, if you're working on a more low-level method, say attribute or property manipulation, anytime you uncover a bug in one of those implementations, you have to make sure that all your dependencies are kept in sync with that as well, or you'll run into the exact same problem that jQuery experienced on a much larger scale, unfortunately, in which a change in a lower level abstraction propagates to other developers' code and results in brokenness. So you either have a choice to stay with the older library indefinitely until that bug gets fixed, or you take a chance and have to rewrite potentially some massive bits of code in order to make that work. So what are some lessons that I think you should take away from this? First is that you need to accept constraints, identify, accept, and embrace them. For instance, at Voxer, because we're creating a client for businesses, we have to be able to support older environments. Unfortunately, corporate environments are not as good about upgrading their browser. It's an unfortunate and sad fact of life, but it is reality. And one of the things that we've realized early on is that many of the design decisions that we make can be radically simplified. We don't have to account for every single possible edge case. Next is to think about exactly what you need. Again, the trade-off here is that it takes a lot of effort to try to plan out your API. But the trade-off is that you'll end up with a lower-level custom build of utility methods that you can use in your application without having to worry about third-party dependencies. On that note is to reduce abstractions and write only what you need. I think this bears a lot of emphasis, because if you start off by trying to write your own general solution, then basically you're going off and trying to re-implement a version of a popular library. And the goal here is to try to simplify and reduce layers of complexity in your application. Trying to re-implement a general solution, basically re-implement jQuery, is not simplifying. All it's doing is shifting the blame from, or shifting the burden rather, from a third-party framework that has dedicated teams and issue trackers and is probably more equipped to handle the bug to a homegrown utility library that may not be fully battle-tested yet. And there's a final note on the slide above that I think is one of the most important ones, and that is have confidence in yourself as an engineer and as a professional developer, that regardless of whichever option you choose, whether you elect to roll your own framework or whether you elect to use a third-party one, that your decision will be the correct one. You know a lot more than you think you might, and for information that you don't know, it's always a Google search, a spec read, or a blog post away. So thank you for your time.
Okay, thank you so much. Hello. Hello, everyone. Okay, so I have a minor apology to give you. We were hoping to have a coffee break right now, but the coffee's not quite ready. I apologize. Yeah, I know. I want coffee too. It's coming soon, but we're going to roll right into our next talk, and hopefully it'll be ready when that's done. So I want to introduce our next speaker. Are you ready?
Well, I need to plug
You ready?
in.
Okay, sweet. Ite Niemann. He's going to talk about big data, and he will start off our big data track. We'll have a couple speakers on that topic. So thank you very much.
I'm going to wait for it to show up on the screen. Oh, okay. Let me do that real quick. How's everybody doing so far? Good? I'm sorry I'm stealing your break, but you'll have it later. Mirror. This is more important anyway. Mirror is on.